Hello everyone, welcome to my channel. If you are new to this channel, please subscribe, like, share, and comment my video lectures. Today we will see the freshman course, the first chapter of freshman course, which is about preposition and set theory, logic, propositional logic, and set theory. So the first section is about prepositional logic. So let's continue our discussion. So if you are new to this channel, I recommend you to subscribe the channel. I will release a sequence of video lectures on this freshman course. So as an introduction, let's see what logic means. Logic is just the foundation of mathematics, and it's a study of reasoning and or good arguments, and it provides a base for interpreting mathematical statements and a tool by which one demonstrates the truth or falsehood of statements. This also gives a powerful tool in analyzing the validity of reasoning about the truth in general. Prepositional logic is a study of prepositions, true or false statements, and a way of combining them with logical operators to give a new preposition. So just like arithmetic operators, addition, subtraction, division, and multiplication, they act on numbers to give a new number. Just like that, logical operators such as conjunction, disjunction, implication, by implication, and negation act on prepositions to give a new preposition, and that new preposition is called a compound preposition. So a prepositional logic is used in artificial intelligence for planning, problem solving, in intelligent control, and most importantly in decision making. So they are applicable in different areas of sciences. So a truth value of a compound preposition, which is formed by the component prepositions, depend on the truth values of the simple prepositions that form the compound preposition. And this makes it easy to specify the effect of the logical operator. And we simply list the truth value of the compound preposition for every combination of the component prepositions. And that list is said to be the truth statement. So when we define what we mean by preposition, is a preposition is a statement, or we can say it's a statement is a declarative sentences that is either true or false, but not both. You see, you may be given a declarative sentences. So from that, if you have obtained, if you are able to say it's true, or you can say you are able to say it false, then you can say that that is a preposition. But if you have cannot able to say true or false, then that one is not a preposition. For example, you can take this one. 2 is a prime. 2 is an even number, which is true. Is that not? Similarly, triangle has 4 sides, which is false. We know that triangle has 3 sides. An impeded set is a subset of every set, which is clearly true. So you can see that these 3 sentences are prepositions. They are prepositions. And let's take the next one. May God bless you. You can see this one. Can you say either true or false this statement? May God bless you. It's not possible. Give me that book is also not possible to say true or false. What's your name? Maybe someone may give his name, but he cannot say true or false. Of all games I will like football every match. Similarly, this one's not also true or false. So such so prepositions like these ones are not statements like these ones are not prepositions. So in general, an interrogative sentences, and exclamatory sentences, and sentences that expresses your belief, attitude, feeling, and hopes are not prepositions. So interrogative sentences mean that sentences that ask questions. which means WS questions. When will you visit your mom? Where do you live? Where shall we go? Just like these ones are interrogative sentences, are not prepositions. Exclamatory sentences are sentences that express strong emotions. How, wow, what a beautiful flower. Wow, how happy I am. Just like these ones, exclamatory sentences are not prepositions. And sentences that express your belief or hope or attitude are also not sentences, so prepositions. Just like this one, I will join medicine department. I will have a job after 4 years. You see, these sentences are hopes or beliefs or attitudes of your feelings. So this type of prepositions, so prepositions, interrogative, exclamatory sentences are not prepositions. Logic, let's come to the logical connectives or operators. So a declarative sentences are commonly occurred in mathematical speech or elsewhere, and they are constructed by modifying the sentences with the word not, or by combining connecting sentences with the word and, or if then, if and only if. We can say connectives are operators that are used to combine one or more prepositions. So most of the time in this course, or every time, we represent prepositions by lower letter Roman, by lower letter Roman letters, P, Q, just like this ones, lower letter English words. So let's see each of the connectives by one. The first one is negation, which is not. If P is a preposition, then the negation of P will be P. This one, the negation of P is represented by this one. The negation of P, this one, is denoted by this one. When it's translated to simple English, mean that it's not the case that P, or simply not P. The negation of every preposition P is mean that it's not the case that P is true or simply not P. So the truth value of negation of P is the opposite of the truth value of P. So, for instance, if P is a preposition, 2 is less than 5, then the reasonable statements of negation of P are, it is not the case that 2 is less than 5, and 2 is not less than 5, you can say. You can do this one. So the truth table for a negation preposition is you have P, we have P2, when P is true, or P is false. When P is true, negation of P becomes false. When P is false, negation of P becomes true. Then the next operator, logical operator, is conjunction or and. Conjunction of a preposition P and Q is a compound preposition P and Q. We denote it by this one. We denote it by this one, P and Q. The compound preposition P and Q is true if P and Q are both true. Otherwise, it's false. Otherwise, it becomes false. It becomes false. For instance, the compound preposition 4 plus 4 is 8, and Sunday is first day of the week is a true statement. But 2 plus 4 is equal to 7, and the melting point of water is 52 degrees, which is false. So the truth table that defines the conjunction. So we have said that if two prepositions are connected by a conjunction or and, then we get a compound preposition, and that compound preposition becomes true if P and Q are both true. Otherwise, it's false. So we have possible cases of truth values. So true, true, false, false, true, false, true, false. Then true and true is true, and true and false is false, false and true is false, and false is also false. So this is a conjunction. The next logical connective is disjunction, or we can say or. The disjunction of a preposition P and Q is a compound preposition P or Q, and it's denoted by this one. It's denoted by this one. The compound preposition P or Q is false if and only if both the prepositions P and Q are false. Otherwise, it's true. Otherwise, it's true. For instance, compound preposition 2 plus 2 is 4, or Sunday is the first day of the week is true. And 3 plus 3 is 7, or the freezing point of water is 32 degrees is also true. But 2 plus 2 is 5, or Gondar is in Kenya is a false statement. So when two simple prepositions are connected by this junction, the compound preposition formed by or is false if and only if both the two simple prepositions are false. Otherwise, it's true. You can see from the table, when P and Q are true, it's true. When P is true and Q is false, it's true. When P is true and Q is true, false and true, it's true. And when both are false, it gives a false statement. It's false, compound preposition becomes false. So this is the disjunction logical connective. The next one is implication, or we can say if-then conditional statement. An implication is a compound preposition of the form if P then Q, or P plus Q. We can say that P, if P then Q, or P plus Q. We denote a compound preposition P implies Q is denoted by this one. It's P, this one, just like this one. The compound preposition P implies Q becomes false if the first statement P is true and the next statement Q is false. Otherwise, it's true. So you can see from the table, from the implication table, P and Q are given when P and Q are two statements and compound statement formed by the implication or an if-then logical connective, then the compound preposition becomes false if the first statement is true and the second statement is false. It becomes the compound preposition becomes false. Otherwise, which means that in the other possible cases, we get a true value. So true implies true is true. True implies false is false. False implies true is true. False implies false is a true statement. So this is how implication is used. So implication has many phrasings in English. So there are various ways of expressing it, such as if P then Q, P implies Q, P is sufficient for Q, and Q is necessary for P, Q, if P, Q, whenever P, Q follows for P, and P only if Q, and Q unless negation of P. So these are possible ways of expressing the logical connective implication, conditional statement implication. So these are possible ways of. The next one is the next logical connective is by implication, or if and only if, or we can say it's biconditional. So the biconditional or the by implication of a preposition P and Q is a compound preposition P if and only if Q, or P is a necessary and sufficient for Q. We can say it. We denote it by this one. We denote it by this one. And the compound preposition P by implies Q is true if P and Q have the same truth value, which means both have true or both have false. Then the compound preposition becomes true, and otherwise it's false. It's false. It's false. If they have different truth values, the truth values also the compound preposition is also false, becomes false. So if we have two compound simple prepositions which are connected by the implication, logical connectives, then the truth value of the compound preposition becomes true if they have the same truth value, if the compound prepositions have the same truth value. So true implies true, it's true. True implies false, it's false. False implies true, it's false. And false implies false. So false by implies false is true. You see? True by implies true is true. True by implies false is false. False by implies true is false. And false by implies false is a true statement. So this is how by implication is applied. Another one is a truth table. A truth table is just a lists the truth value of a compound preposition for every combination of truth values of its components. So the truth table are a basic tool for prepositional logic, and note that if a compound preposition has n simple prepositions, then the truth table must have to the power of n rows. It must have to the power of n rows, where 2 is every simple preposition has two choices, true or false, which are true or false, which has two choices. So to the power of n, where n is the number of prepositions that are included on the compound preposition. So to find, to construct the truth table for a compound preposition, the number of rows is obtained by to the power of n, and the number of columns are the number of simple prepositions. The number of columns are formed by the simple prepositions that are included in the compound preposition. So let's see how to construct a truth table for the given compound preposition. So in case of two statements that we have, when we have two statements, then two prepositions, we have to the power of 2 is 4 possible truth values, So we give the first statement, simple component statement, half of the 4. We have 4 truth values, so we divide 4 by 2. So give 2 of the first true, and the next false. And the next one is the next preposition is dividing this 2 by 2, which is 1. Therefore, we give true, false. Just after that, we will apply the logical connectives. And when we have 3 statements or prepositions, to the power of 3 is just 8. So when we divide 8 into 2, so it gives 4. So the first preposition on the first simple preposition will give true, and the next 4 becomes false. In the second preposition, simple preposition, you will divide this 4 by 2, and then 4 by 2 is 2. So you will give the first 2 true, and the next 2 false, then true, and then false. And the last one is dividing 2 by 2, it will give 1. So you will shift true and false on the rows. So true, false. Just after that, you will apply the logical connectives. So as a remark, when we are dealing with compound prepositions, we shall adopt the following convention on the use of parentheses. So whenever we are using negation or and or occurs with implication by implication, we always apply first the negation and or, and then we apply the implication by implications. For example, if we have this one, P and negation, P and Q implies R. Clearly, you can see that there is no plus, but always we should apply the end, the prepositions we are connected by end, like this one, we apply like this one, P and Q, then first we apply this one and then apply the implication. Similarly, negation of P implies negation of R will be done as negation of P. You will apply negation of P first, and then negation of R first, then second, then apply the implication. Okay. So this is the order of how we apply the logical connectors, just like arithmetic operators. We use body mass, just like that. We use logical connectives in such a way. So let's construct the truth table for these compound prepositions. So as you have seen that P implies negation of Q or P and R. So we have three logical three prepositions, simple prepositions. So to the power of 3 is just 8. So we have 8 truth values for possible truth values of the prepositions. So when we are dividing 8 into 2, so we will give the 4 by true, and the next 4 will be false. And the next preposition dividing 4 by 2, which is 2, you will give true, the first 2, the second 2, second 2 are false, and the next 2 are true, and the next are false. And dividing 2 by 2 will give 1. So sequentially we give true and false by giving true, false, true, false, true, false by changing the truth values. And the next one is we will do the negation sequentially. We will do negation of Q, which is Q is this one. So the negation of this one is true, true, false, 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 true, 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 false, 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 true, true. We give it. And the next one we will do P and R. P and R. Let's do this one. P and R. Do you remember when we are combining two simple prepositions by and the truth value for the compound prepositions true if was P and R are true. So clearly you can see that this one is true, and the next one is also P and R is this one is true, and the next one is false, and the next one is true, and the next one is clearly false, and the next one is also false, and the next one is false, and the next one is also false, and just like this one. Like this one, and the last one is false, and false is also false. So we obtain this one, and the next one is negation of P, negation of Q, or P and R. P and R. So P and R is this one, P and R is this one, and this one is negation of Q. When we are connecting two prepositions by or disjunction, the compound preposition becomes false if both the simple prepositions are false, otherwise it's true. I think you know this one. So this one becomes true, and this one becomes false, this one becomes true, and this one becomes true, and this one becomes false, this one becomes false, and this one becomes true, and this one becomes a true statement. You see? And the last one is implication. So P implies this part. P implies negation of Q or P and R. So negation of Q or P and R is this one, and P is this one. So when we are connecting two prepositions by implication, by implies, we can say that the preposition, that compound preposition becomes false when the first statement is true and the second statement is false. Is that not? So just applying that, true and true is just true, and true and false is clearly false, and true implies true is true, and true implies true is also true, and false implies false is also what? It's true, it's true. False implies false is also true. False implies true is it's also true, and false implies true is this one's also true statement. So clearly you can see that how we can construct the true statement for a given compound preposition by applying the sequences of the logical connectives. The next example is construct a true statement for the statement, the preposition P and Q or negation of R. Clearly, you can see that we have three statements, then to the power of 3, which is equal to 8 possible combination of truth values. Therefore, we can apply this logical connectives by using the values, the property of the logical connectives. We can find the truth table. We can construct the truth table for the compound preposition. So since we have 8 possible combinations of truth values, so we have the first one, with 8 divided by 2 is 4. We give the first 4 rows by true and the next 4 rows by false, and divided this one by 2. 4 by 2 is 2, so you give 2 true for the first 2 rows and false for the next 2 rows, and true for the next and false for the next, and dividing 2 by 2, which is give 1. So you will alternate true and false in each row. True, false, true, false, true, false. In the negation of R, the first one is negation of R. which is negation of R is negation of true is false, the negation of true is false, and the negation of false is true, the negation of true is false, and the negation of false is true, the negation of true is false, the negation of false is true, the negation of true is false, and the negation of false is true. The next one is P and Q, P and Q, P and Q. And the next one is P and Q. So P and Q, just P and Q, P and Q, and then when we are connecting simple preposition, two simple prepositions by a logical connective and, the compound preposition and becomes true when P and the two simple prepositions becomes true. Is that not? Therefore, we'll give P and Q is true, true is true, and true, true is true, and true, false is false, true, false is false, and false, true is false, false, true is false, false and true, false and false is false, false and false is also false. It is also false. Now we have just used this one. The next one is combining the two prepositions, combining the two prepositions.